All right, so 2.1 basics of functions and their graphs. So we're kind of moving into a new topic, and that's going to be all about functions. That's what this chapter will look at. So first of all, what is a function, right? Well, first let's look at what a relation is. So a set of ordered pairs is called a relation. So you can have sets of ordered pairs of whatever you want, letters, numbers. You can insert whatever you want as pairs, and those could be known as a relation. A relation can be represented in several different ways. Ordered pairs, you could even set up a table and a graph and a mapping or an equation. So here's an example of all the different ways you can do that. So here's the ordered pairs. So X goes first and then the Y value. That's how we set that up. You can make a table. Okay, you can graph it right here. So you have an x-axis and a y-axis. This is the positive direction for x. You always start at the origin right here. That's the positive. This is the negative direction. And then with y, this is the positive direction. This is the negative. So if you look right here, the ordered pair 1, 2. So my x value is 1, so I moved over 1. And then I moved up 2 spots right there. And so then I land right there. One more we'll look at right here. If I have negative 2 for x, so I go backwards 2, and then I shoot up 4 spots right there for the y value to correlate with that one. And then we also have a thing known as a mapping. It's kind of like having a table, but sometimes the arrows can point in different directions. But basically, you just have your assigned domain, which that's just a fancy way of saying your x values right here, and then range is going to be your y values right here. So basically 1 pairs to 2, -2 pairs to 4, and 0 pairs to -3. And so really those once again are just ordered pairs. You can see from all the other representations it's the same relationship. All right. So the x values of the relationship are known as the domain. So I had just mentioned that. So if you were asked what's the domain of this example up above, you would list the set of numbers -2, 0, 1. They put it in numerical order. If you don't put it in numerical order, that's okay. It won't be counted wrong. But typically we try to put those in numerical order. And then the y values in the relation are known as the range. And so they're the y values from our example. So as I was saying in the beginning, you can create any type of relationship you want, but once you get into the function phase, there's a couple more rules that we have to follow, and that's what we're going to look at down here. So for a relation to be a function, there must only be one output of y for each input of x. Simply, x cannot have more than one partner. If these conditions are met, we say that y is a function of x. So the way a function works is we like to plug in x. So we plug in x and we only want one output to come out. If you get two different results, then it's not considered a function. Functions, you want to picture it like as a machine. Um, you put something in and one thing is supposed to come out. You don't want to get multiple results. And so usually we use functions for data and stuff like that. So here we're going to determine whether each relation is a function, and then we're going to go ahead and list the domain and range for each relation. So first question, is it a function? And the answer is going to be no. And the reason why is because x has two different pairs right there. So when x is 3, the we're getting two different results back, and so that means it's not a function. It's still a relation, but it's not a function. And you see we have the same problem right here with 4 pairing up with two different results, and so it's not a function. The domain here is going to be 3 and 4. You don't need to list it twice, even though it shows up multiple times. Just list it once whenever you're asked for domain. And then our range looks like we have 4, 5, and then 4 and a 5 again. And so once again, you just need to list that one time. So we'll do that there. On our next example, It looks like we're okay because you notice my x value is 3, 5, 7, and 4. And so I don't have a repeat. Now you might be like, well, wait a second, -2 shows up twice for the y value. That's okay. That's not a problem. It's just that x can't show up twice. So this one is a function, so yes. And then our domain in here, let's see, 3, 5, 7, and 4. So you notice I didn't quite put them in numerical order because I just went from left to right. So it's not a big deal that the 4 is at the end. It's not a problem. Now let's see range. Let's see, we're going to have -2. -2 again, but don't list it a second time. And then let's see, 1 and then 9. So that's going to be our range right there. Okay. And if you've never really kind of dealt with functions, it's probably pretty weird, some of the terminology and what we're talking about. But as we, the whole chapter is devoted to functions, so we're really kind of just touching the surface here. So don't get overwhelmed. We'll get more in depth on some of the stuff as we move forward. So remember, x can't have more than one partner to be a function, and that's where this next thing we're going to look at called the vertical line test comes in. So we looked at determining whether we have a function by looking at ordered pairs. Now we're going to be able to look at a graph and decide whether it is a function or not. So the vertical line test, to be a function, every x value can only be paired with one y value. Therefore, if any vertical line intersects a graph in more than one point, then the graph is not a function. To run this test, all you have to do is drag a vertical line across the graph. So let's go ahead and do that here. We've got this vertical line right here. So we can see this first one is not a function because it touches at more than one point at a time. And let me kind of show you that. So I'm going to go ahead and put no here. Because see, for example, right here, these two ordered pairs, I'm just going to estimate that the x value is like 3. So at this point, it's like over 3 up 1, and then over here, it's over 3 down 1, right? And so see, when x is 3, I'm getting two different results. And so it is a relation. Remember, it's okay to be a relation, but it doesn't qualify as a function. So no, it's not a function. Then if we look at our next one right here, this looks good. It doesn't touch at more than one point at a time on the line. So any x value, I only get one y value in return. So that is a function. Same thing with part C. That looks good. So both of those are going to be yes. So let's go ahead and mark that. Yes, it's a function. And on your homework, I think it says y is a function of x. So see, y is dependent on what x is. And so yes. And then let's look at part D. This one would be no again, the same idea from example A. You can see that the x value, whatever this x value is right here, the problem is I'm getting two different results. So this one would be no. Okay, now one of the harder ways to figure out if we're dealing with a function or not is with an equation. Now, I'm going to kind of break it down for you and give you kind of an easy way to figure this out. But for most students, it can kind of be a little bit challenging, but I give you a little hint here. So determine if the equation defines y as a function of x. We're doing the same thing we were doing with the vertical line test, just that now we're given an equation, so we have to come up with another way of figuring this out. And so I basically kind of just give it away here. Hint, if y is an even power, then it will not be a function. So if the exponent for y is even, not a function. Also, inequalities are not functions. We don't have any inequalities here, but in other textbooks I've used in the past, I have seen that be the case, where they'll throw an inequality in there, so I just thought I'd mention that. Okay, so really all you have to do is look at if y is an even power, then it's not a function. So you can see that here on number 15 and number 17, and that's it. So those two are not functions, and I'm going to show you why in a second. But let's go ahead and take these one by one. So the first one, if you were to graph this, it would be a line. Okay, and we're gonna spend, or actually, you should be familiar with graphing lines, and so we'll do a little bit of graphing lines, but not too much. The next one is going to be a parabola. And so let's see. And you probably should be familiar with how that looks. It's going to be kind of a U-shaped. It's going to be kind of U-shaped. And then number 15, actually, if you were to graph this, which you can, it's actually a circle. Okay. Now let me kind of show you why this is not a function by showing you ordered pairs. So let's see. So for every x, I can only get a unique y. So if x was 0, y could be 4 because 4 to the power of 2 would give me 16, right? But if x were 0, y could also be negative 4 because when you square a negative, it becomes positive. So negative 4 times negative 4 would be positive 16. So that kind of shows you how x could have two different results, which makes it not a function. All right. And same thing with number 17. So by the way, if you want to know what this one looks like, it looks like a parabola on its side. So it looks pretty similar to number 13. It's just on its side. And so once again, I could make up some values here. So x could be like um, let me fix that. Let's see. X could be like 4. So y could be a 2, or y could be a negative 2, because negative 2 squared would still be a 4. So that one's not a function either. So I'm just going to put no. This one is, just if you want to know what this one looks like, I'll graph this how it looks. It looks like a half of a parabola on its side. So it kind of looks like number 17, but it's only half of it. So it would qualify as a function. You can see that it would pass the vertical line test. And then the last one, if you were to graph this, and we will graph problems like this eventually, it actually kind of looks like the half of a parabola on its side going one way and then going the other way. So you don't really need to worry about how these look because we'll take each one of these individually later and we'll spend plenty of time talking about each one. So you don't have to worry too much. I just wanted to give you kind of a visual for each one of these. All right, so what we'll look at next is function notation. So find the function values. Equations that are functions can be written in a form called function notation. So we have an example right here. So here's an equation, y equals 3x minus 8. The function notation, all you do is just change the y to f of x, okay? So don't overthink this. That doesn't say f times x. It's just read f of x. And the reason why is what we'll do is we'll replace that x with what value we want to substitute into the equation for x to solve for y, right? So instead of having to say let x equal 5, so instead of having to say let x equal 5, I know it's not a big deal, but instead of having to say that, we can just do f of 5. And that's basically saying, okay, the x value is going to be 5, plug it in and simplify to get the y value. So I plug it in, 3 times 5 is 15, take away 8 is 7. So f of 5 equals 7. What that basically means is when x equals 5, y equals 7. That's all we're doing here, okay? So let's go ahead and try. I think I got about 5 of these, 5 or 6. Okay, so right here, 27. F of x is equal to 4x plus 5, and so we want to know f of 6. So all I'm doing is I'm going to replace the x with the 6 and then simplify. So we're going to have 4 times 6 plus 5. 4 times 6 is 24, plus 5 is 29. And there you go. That's it. Okay. The next one is kind of interesting because we're plugging in more than just a number. We're plugging in a variable. So we're going to plug in x plus 1 for where you see x. Okay, so this is going to be 4 times x plus 1 plus 5. Now, it's very important that you put the x plus 1 in parentheses. And the reason why is the 4 is getting multiplied to all of x, whatever we're substituting in, right? So not just the x, but also the plus 1. So what we're going to have to do here is distribute the 4. So we're going to get 4x plus 4, and then we have a plus 5 right there. And we do have some like terms we can combine, so you always want to simplify if possible. So we'll go ahead and combine that. So we're going to end up with 4x plus 9, and that's our answer. And you want to stop there. Very common mistake students will make is, I don't know why they do this, but all of a sudden they'll add an equal 0, and they'll start trying to solve for x. So don't solve for x. We want to go ahead and just stop right there. That is our answer, okay? All right, our next one, we're going to do f of negative x. And so let's see, I'm going to have 4 times negative x and then plus 5. So let's just clarify something real quick. Negative x is just the same thing as negative 1 times x. Okay, so it's kind of shorthand for saying negative 1 times x. So basically we have a understood negative 1 in front of x. And so what we're going to do is multiply that with the 4. So that will become negative 4 times x, or just negative 4x. And then we still have the plus 5. Don't forget about that. And then once again, don't try to go any further than that. That is our result right there. All right, our next one, here we go. So we have our g of x is equal to x squared plus 2x plus 3. So this time you're going to notice that x appears twice on the right side. And so you're going to plug in negative 1 in both places on our first example. So we're going to have negative 1 squared plus 2 times negative 1 and then plus 3. And we're going to go ahead and just simplify this. So negative 1 squared, negative 1 times negative 1 is a positive 1. Then we have a plus 2 times negative 1. So you can go ahead and put this as a minus 2 or plus negative 2, whatever you're comfortable with. Okay, you could have just put it as minus 2 if you'd like. And then we have a plus 3 right here. And then now it's time to combine all these like terms. So 1 plus negative 2 is negative 1. And then negative 1 plus a positive 3 will come out as a positive 2. So our final result is positive 2. So just go from left to right. 1 plus negative 2 is negative 1. Then plus 3 gives me that positive 2. Okay, part B, once again, we're going to plug in an expression that has a variable with it right here. So x plus 5. So let's see what we got here. We're going to have x plus 5 squared plus 2 times x plus 5, and then a plus 3. Okay, the most common mistake we'll see on this problem here is students will just square the x and the 5, and that is not correct, okay? So you know if you square something, like for example 3 squared is 9 because it's 3 times 3, which equals 9, right? 3 squared is 9. Well, x plus 5, if you're going to square it, it's going to be x plus 5 times x plus 5. And what we're going to have to do is we're going to have to go ahead and FOIL that. So I'm going to go ahead and take care of this real quick before we move on to the other parts. So x times x is x squared. X times 5 is 5x. 5 times x is another 5x. And then 5 times 5 is 25. And then we'll combine those like terms in the middle. So we've got x squared plus 10x plus 25. So if you would have just squared it and got x squared plus 5 squared, that is not correct. That's not the same thing that I have down here. So just be careful. Squaring a binomial, there is a pattern to that. Whenever you square a binomial, you basically can just square the first term, which gave me that x squared. And then you can multiply the two terms together and double it. So x times 5 is 5x, positive 5x, and double it to plus 10x. And then square the 5, and that will give you a 25. So that's kind of a little shortcut. If you're familiar with that, great. If not, it just takes, less than a minute to break it apart and FOIL it. So make sure you do that extra step if you need to so you don't make any mistakes. All right, let's look at the rest of it. So here on this part, we're going to distribute the 2. So that'll give us a plus 2x and a plus 10. And then we need to bring the plus 3 down because we still have that 2. All right, so now it's time to combine our like terms. So we have an x squared. I don't see any other x squared, so we'll go ahead and put that at the front. Then let's see, we've got a plus 10x and a plus 2x. That combined together is a positive 12x. And then we have 25 plus 10, that's 35. And then plus another 3, that'll be plus 38. And that is our answer right there. Okay, our last one for this equation is g of negative x. So we're going to plug in a negative x. So we're going to have negative x squared plus 2 times negative x and then plus 3. Okay, so remember the negative x is just really an understood negative 1 in front. So when you square it, negative 1 squared just becomes positive 1. So what's going to happen to this first part is it just becomes positive x squared. It's just positive x squared. Clean that up a little bit. There we go. Positive x squared. Then you have plus 2 times the negative x. So positive and the negative. So it's going to become plus negative 2x, or we're going to go ahead and simplify that to just a minus 2x. If you had plus negative 2x, it's not incorrect, but this is considered to be more simplified. And then we have the plus 3 on the back end right there. And that's what we're looking at for that one. Okay. A few left here. Okay, so looking at 31 here. We're going to go ahead and plug in 2 to get started. So let's see, we're going to have 2 to the power of 4 minus 2 to the power of 2, and then plus 1. Okay, 2 to the power of 4 would be 2. Let's see, just make sure we know this. Let's see, 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. And then 4 times 4 is 16. So that gives me 16. And then, look, minus is part of the formula, so that's going to come down here, and you're squaring the 2. Don't square the negative, okay? So 2 times 2 is 4, so don't turn it into a positive. That is a minus, not a negative sign that belongs to the 2. It doesn't belong to the 2, okay? And then we have a plus 1, and now we'll go ahead and combine these constants. So 16 take away 4 is 12. 12 plus 1 is 13. And there we are. Okay, on part B, we're going to plug in negative 1. So we have negative 1 to the power of 4 minus negative 1 to the power of 2. Then we have plus 1. And so negative 1 to the power of 4 would become a positive 1. Okay, let me see if I have enough room to kind of show that real quick. So if you had negative 1 times negative 1 times negative 1, so on. So see, negative and a negative become positive 1. Negative and a negative become positive 1. Then positive and positive, that's where we get our positive 1 right there. Now, once again, we take the minus sign with us. Now, this time, the base does have the negative here. It's negative 1 squared. Negative times a negative is positive. It becomes positive 1, but the minus is still there. And then we have a plus 1 right here. So let's see. 1 take away 1 is 0. 0 plus 1 is 1. There we are. All right. So on our part C, we're going to plug in a negative x. So let's see, we're going to have negative x to the power of 4 minus negative x to the power of 2, and then a plus 1. Now, right here, you know, you have that understood negative 1 in front. And what I showed you up above, if you have -1 to the power of 4, it does turn +1. So that's going to cause this to turn into a positive x to the power of 4. Then we do have our minus sign. And then once again, I have that understood -1 in front. So when it gets squared, it becomes positive. So it's going to be positive x squared. And then we have that +1 right there. And there we go. Now, what's interesting about this one is nothing changed. So when I plugged in -x, I actually got the same that I started with. And that's something we'll talk about in a different unit whenever we have that phenomenon. Okay, let's look at D. So we're going to plug in 3a. Interesting. Okay, so we're going to plug in a variable with this. So let's see, 3a to the power of 4 minus 3a to the power of 2 plus 1. Okay, so what's going on here is we have terms getting multiplied together. Now, if you remember up above here, when we were adding, we had to break it apart and FOIL it, okay, because we were adding. And you'd have to do the same thing if you were subtracting. If you're adding or subtracting, you have to break it apart and FOIL it. If you're multiplying or dividing, you don't, okay? And so the formula for this is if you have AB to some power, that power goes to both the A and to the B. And that'd be the same thing if I had a fraction. If I had A over B to some power, that power would also go to both the numerator and the denominator. So what I have to do here on this example is I'm going to have to raise both of these to the power of 4, the 3 and the A. So 3 raised to the power of 4 is going to be 3 times 3 times 3 times 3. 3 times 3 is 9, and I can get another 9 right there. And then 9 times 9 is going to be 81. And then I'm going to have a to the power of 4. Okay, so that's the first part. Then we'll go ahead and do this part. Now the minus comes down, right? The minus will come down. And so I have to square both of these. So 3 squared is 9, and a squared is, well, a squared. And then we have the +1 right there. And that is my answer. That's it. All right. I got one page left. Let me see. All right. So here we're going to plug in 3. So 3 to the power of 3 minus 3 plus 1. 3 to the power of 3. We're going to do 3 times 3 times 3. So let's see, it's going to be 9 times 3. That's going to be 27. Then minus 3 plus 1. All right. 27 minus 3 is 24. 24 plus 1 is going to be 25. So that's going to be the answer to part A. Okay. And let's see, on part B, we're going to plug in -2. So we're going to have -2 to the power of 3 minus a -2 and then plus 1. So I'm just plugging in -2 in both spots. So -2 to the power of 3. So I got to do -2 times -2 times -2. All right. So a negative times a negative, that'll become +4, but then I have to multiply it by -2 again, and that turns the first term into a -8. So I actually end up with -8 for this first column right here. Then in my second term right here, I'm subtracting the negative, so that will become a +2. And then I have the +1 right there. So we'll go ahead and combine all this. So let's see. -8 plus 2 is -6. And then -6 plus 1 would give us a -5. So we end up with -5 on part B. Okay, looking at part C, I'm going to go ahead and write this down here so just have a little bit more room. So let's see, h of -x, so I'm going to have -x to the power of 3 minus a -x, and then plus 1. Okay, this time, I have -1 to the power of 3. That actually is going to stay negative. because if you do -1 times -1 times -1, you'll get a +1, but then you have to multiply it by -1 again, so you end up with a -1 right there, right? So that means that the leading term will be negative. So we're going to have a negative x to the power of 3. Okay, that's the first term. The second term, you're subtracting the negative, so once again, that'll turn into plus x, because you're subtracting the negative. And then we have the +1 right there. So that is our result for part C. Our last part, part D, let's see, h of 3a. So we're going to have 3a raised to a power of 3, then minus 3a, and then we have a +1. So I have to cube both of these. So 3 to the third power is going to be 27. 3 times 3 times 3. And then we'll have an a to the power of 3 right here. Then we're subtracting 3a. Then we have a +1. And that is what we're looking at. Okay, 33, we're looking at a square root function. So hopefully we're somewhat familiar with square roots. I'll just do a couple easy ones real quick. So like the square root of 4 would be 2. And the reason why is because a square root basically nullifies a square power. And so see, 2 to the power of 2 equals 4. So that's why the square root of 4 equals 2. So like the square root of 9 would equal 3, because 3 to the power of 2 would equal 9, right? So just a little review on square roots. We'll look at those a little bit closer in another section. But let's go ahead and try these right here. So f of -6. So we're going to go ahead and plug that in for where we see an r right there. So -6 plus 6, and then you have a +3 that's not part of the square root. So you want to just focus on this part real quick. Well, that'll give us square root of 0. And then we have our +3. Well, the square root of 0 is actually 0, because 0 to the power of 2 would be 0. So go ahead and that'll just be 0. And then we have a +3. 0 plus 3 is 3. Okay. Part B, we're going to do f of 10. So we plug in a 10. 10 plus 6. And then we have a +3, but that's on the outside of the square root. So we end up getting the square root of 16 plus 3. Square root of 16 is 4, because 4 to the power of 2 would be 16, right? And then plus 3, so we get a 7. Okay, and then part C, we are going to plug in this expression right here. So we're going to have the square root. So we're going to have x minus 6. And then you still have that +6. I'm going to kind of color code this so we can kind of see that right there. So that's what I substituted right in there for the r. Now looking at the radical, the -6 and +6 will cancel out. So that just leaves me with the square root of x and then +3. Just make sure that the +3 is not inside when you type that in the on your homework. Whenever you have a radical, you just need to arrow to the right to get outside of it so you can put that +3 on the outside. Okay, I know I said this was the last page, but I actually have one last example. So it's not a full page, it's just this one last example, and we're going to look at a rational function. This is known as a rational function. It's a fancy way of just saying a fraction. So we'll go ahead and plug these in and simplify. So I'm going to start with plugging in 2. So we're going to have 4 times 2 squared minus 1 over 2 squared. So what you want to do, you don't want to just start canceling stuff out. I can't be like, oh, I'll cancel out the 2 squares. That won't work. The only way you can do that is if you get rid of all the addition or subtraction and then see if there's any common factors that can get canceled out. So let's see what we got here. We're going to have 4 times 4 and then minus 1. And then on bottom, that'll be a 4. Once again, don't try to cancel out because we have a minus sign right there. So this will become 16 minus 1 over 4. And then we'll end up with 15 over 4. And then they don't have anything in common to cancel out, so we'll leave it like that. Okay, part B is kind of boring because you're going to get the same exact answer because whenever you plug in -2, um, what's going to happen is you're going to get the same thing you see right here because when you square -2, they just turn into positive 4s. -2 to the power of 2, both of those would turn into 4s, and so you end up with the same exact answer. Um, and that's kind of what you see on part C also, because you're going to plug in -x, and basically what's going to happen is we'll get the same exact function in return. So let's see, 4 times -x squared minus 1 over -x squared. So what happens is those negatives will get squared out, so we'll end up with 4x squared minus 1 all over x squared. And so this is a special type of function, and I'd mentioned that earlier, and it'll be something that I don't really discuss until it actually becomes useful, okay? But something to kind of look forward to. So, all right, so this is pretty big introduction to functions, and that's really how the first couple sections will go. It's really just going to be a continuation of where we are right now. I'm just going to continue to introduce new little things about functions.